Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 5, Lesson 2, on adding and subtracting rational expressions. So, this is a more complicated concept than the last lesson, so please pay close attention. To some, it comes easily, but to others, such as myself, when I first learned this, it did not come easily. So it's not really that complicated, I guess, if you understand the concept, but it's kind of easy to make mistakes. So we already multiplied and divided rational expressions, but how do you add them or subtract them? Not the same. So let's start with this example. As you can see, I'm back on my old app because I re-downloaded it and now it is actually working because it was not. It was just a blank screen and it wasn't doing anything. So what do? What's the first thing we need to do? Well, we need to find a common denominator. What's a common denominator? Well, just what it sounds like. We see the denominators. How do we make them common or the same? What do we do to do that? So that's really what it means. So let's just take a normal fraction, for example. Okay. How could we make that a common denominator? Let me just go ahead and tell you the answer. 7/12. So how did we do that? Obviously, we didn't add the numerators and denominators, or we would get 2/7, which is not correct. What did we do? We needed to figure out how to make the denominators the same. That's the only way you can add. So we could do that by multiplying by 4 here and multiplying by 3 here to make them both 12. How did I come up with that? Well, here's what you can do when it's numbers. You have 3, you have 4. You keep adding the same amount to it over and over. So if you add 3, 6, then 9, then 12, 15, etc. Then for 4, we could do 8, 12. Oh, we can just stop. We see here's our common denominator, 12. So basically, then what you say is, how do you make it 12? All you have to do is multiply by 4 for this one and by 3 for this one. Just happen to be the same thing as what those numbers are. So that's kind of what we're doing, but we can't do it just like that because it's polynomials. So we can see here we have 2x plus 8, and then we have x plus 4. Let's try to factor this and see if we can figure out how to make it something more simpler that would look like the other one. So if you, let me just write that back. If you take out, we see that there's 2 and 8. If we take out a 2, then we get x plus 4. Then we see this x plus 4, and how we make them the same is just by having the 2 there, which means multiplying by 2. So if we multiply by 2 on the bottom, we're also going to need to multiply by 2 on the top. That's always what you have to do. So you basically need to factor if you can. And pretty much if your teacher gives you the problem, it should be able to factor to where you would see that they're the same like this. So don't worry about that. So now we have a common denominator of 2 times x plus 4. So now we can just write 5x plus 2 times 3x minus 1. That's our numerator. And then we have, let's really just put this all in parentheses. And then we have on the bottom just what our common denominator was, which was this. Okay, now we need to simplify by distributing, and then you would get 6x minus 2. You combine like terms, and then you get 11x minus 2. And that is all you can do to simplify. So that's how we got this answer. So hopefully that makes sense. You basically just need to factor to make the denominators the same. Once you can, you multiply that thing that was missing out of the denominator. Make sure you don't multiply the numerator by this whole thing, only 2. Why? Because 2 is the only thing that was missing from that denominator. Then you multiply those 2 together, and then you just combine like terms, and that's all you have to do. So that's one example, but let's look at another one. Okay, how about one with subtraction? I have something on my computer, and I'm gonna look for one that has subtraction. I hope there is one on this thing, because like I told you that problems have to have specific things for them to even be able to be solvable. Okay, here's one. Okay, we have 3 divided by x minus 1 minus 2 divided by x. What do we do? First, we need to factor the denominators if you can. Can't. So, now let's see, what can we make it? How can we make them the same? You might just say, oh, minus 1. Well, you can't really do that. Here's why. If you did that, that would not... You have to find something that you can multiply the denominator by, not subtract by. So what we actually have to do, there's nothing we can do to them alone. So we actually just have to multiply them by each other, like this. And here's a tip. You can always multiply the denominators by each other to get a common denominator, but it might not be simplified. Here's what I mean. Going back to this problem, we could say, oh, let's multiply that by 8. Let's multiply that by 6. But would that give us the simplest answer? We would get 8 over 24, and then 6 over 24, which would give us 14 over 24, which does simplify to 7 over 12, which is the same thing we got last time, but it's not the simplest answer. So you can always multiply those denominators, but then you might end up with crazy things like quadratics and then things that are harder to solve. So only do that when you have to, and you do in this case. So then we have to multiply the thing that was missing at the top. Oops. No. Okay, how do I get rid of this thing? Okay, sorry about that. And then you have to multiply that by that. Basically, remember, you multiply the numerators by whatever wasn't already there. So, now we have 3x from that. And then minus 2, do parentheses, I'll tell you why in a minute. X minus 1. And then all divided by, what was our common denominator? X times x minus 1. Now, here is why I said to do parentheses. If you didn't do parentheses, you might just make it only -2, but it can't be only -2. You have to first, we're going to distribute here, but then distribute the negative to whatever that answer is. So when we distribute that, we would get 2x minus 2, then distribute that negative, and then that will be negative and then positive. It just changes the signs. So negative 2x plus 2. So we combine like terms. 3x minus 2x is just x. So x plus 2. And that is our answer. So that is how you add and subtract polynomials. Or sorry, how you add and subtract rational expressions. So I hope that made sense. But just to review, here are pretty much the steps. You first factor, if possible. Make denominators the same. And then you multiply missing term by numerator, and then you combine like terms. So it may seem complicated, but it's really not. So that's all you have to do. So thanks for watching, and I'll see you on the next video about how to solve rational functions.